Very good morning, good afternoon, good evening to all the participants for this course. The title of which is under the NPTEL MOOC is Application of Forecasting Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, today is the fourth class for the first week, and as you know, each week we will have 5 classes of half an hour each, and after the set of 5 classes are over, you will have the first assignment. Similarly, after second week, and it will continue for 12 weeks accordingly to cover the whole 30 hours lecture which has been planned. So, as you know, the 3 broad areas where we are going to discuss, again I am saying with examples and not much of a theory. One is the averaging techniques or forecasting, which we are doing now, then we will go into multiple linear regression, and then the last part being time series analysis. So, this is the area of averaging techniques and forecasting concepts which we are covering. This is fourth lecture, as I have already mentioned, under week 1. Now, what would be the coverage? So, if you remember in the last class, we were discussing about the different sequence of the discussion was. What was basically how the forecasting models were implemented, considering the model was selected, data cleaning, then applying it, and then checking the efficacy of the models. So, then we discussed about what are the different metric based in which the analysis can be done. Metric not for the finding out which is the best model, but metric to find out the characteristics of the data set. So, say for example, we had the mean, median, mode, variance, standard deviation, mean absolute deviation, weighted mean absolute deviation, mean square error, mean weighted mean square error, covariance, correlation. So, we will discuss that accordingly. And if you remember, all the formulas were given, we will consider a very simple data set and try to analyze it. And then when we proceed for bigger data set for forecasting, then we will only give the results. Here basically the steps of how we do the calculation would be discussed. So, the coverage would be forecasting some numerical characteristics which are used, and the matrix for forecasting we will discuss. So, let us consider first a data set X. I am mentioning X, Y you will soon understand. So, we have a data set X, I will mark it with yellow. So, the numbers are 2, 3, 4, 5, 6, 6, 6 occurs twice, then 7 occurs thrice, 21, 21, which is 21 occurring twice, and 102. So, the total number, if you see, is basically 12 in number. So, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, n is 12. Based on that, when we find, I will use the red color because the yellow one may not be very well distinct, or let me use the black one and highlight it accordingly. So, when I find out the mean, so the mean would be which is given as 15.9167. So, it can be calculated by finding out the sum 2 plus 3 plus 4 plus 5 plus 6 plus 6 plus 7 plus 7 plus 7, because 7 occurs 3 times, plus 21 because 21 occurs twice, plus 102 divided by 12 gives you the answer as 15.9167. If I try to find out then the median would basically be the middle value. Now, remember, middle value in the sense it is going to divide the total distribution into 2 distinct half of probabilities 0.5, 0.5 each. So, if I consider the total set of values, it is 12. So, obviously, there is no middle value, it will be between 6th and the 7th one. So, the 6th one is what you have is basically 1, 2, 3, 4, 5, 6. So, 6th one is number 6 and the 7th one is number 7. So, the average of that would basically be given by I'll use a different color, consider it's green. So, if I use it, this will be 6 plus 7 by 2, middle of that basically comes out to be 6.5. Now, when I go to the mode is basically the one which is occurring maximum number of times, for which the corresponding probability the highest. So, if I consider all the numbers, the number here which you see 2, 3, 4, 5 occur only once out of 12, total number is 12. 6 occurs twice, 21 occurs twice, while 7 occurs 3 number of times. So, obviously, the one which is occurring maximum, which is the 7th one, hence the mode is basically 7th. Now, if I go to find out the variance, now considering the variance we are using the formula, I have this, I will change the color. So, consider this is orange. So, that would be, if you remember, it is 1 by n minus 1, n is 12. So, 12 minus 1 is 11, and the variance is calculated by the formula as xi minus the mean value of x whole square. So, what is mean value of x is given as 15.9167. So, what I should do is basically this, I will tell it verbally slowly and you will understand. The first square would be 2 minus 15.9167 whole square. To that you will add the second term which is in the bracket, which will be squared, is 3 minus 15.9167, that is squared, plus the third term is 4 minus 15.9167, that whole square. The next term would be 5 minus 15.9167 whole square, and it will continue till the last value would be 102 minus 15.9167 whole square. You add up all the squares, that is the difference of the numbers with the mean, they are squared and you add up all of them. So, there are 12 terms. Once you do that, you will basically divide by n minus 1, because it is for the sample. Remember, even though I am writing mean, median, mode, variance, standard deviation, they are with respect to sample. If you remember, I mentioned it time and again when the formulas were being discussed. So, you will have basically the variance, and the variance comes out to be, I use the color orange here, this comes out to be 774.4470, and the standard deviation is square root of that. The square root of 774.4470 would basically come out to be 27.8289. So, I will use another color, say for example, dark red, and this is the standard deviation which you have. So, given this data set of x starting from 2 to 102, where 12 numbers are there, I find of the sample mean, sample median, sample mode, the variance, sample variance, and the sample standard deviation. Now, to continue the other values, the mean absolute deviation would be, if you remember, the mean absolute deviation was given by the formula where I find out the difference of the values with respect to the mean with positive sign, because you are using the mod, and basically add them all up and divide by 12, because 12 was n. So, the mean absolute deviation for x for the sample comes out to be 16.0417. If I find out the mean weighted absolute deviation, considering the weight you are assigning for each of this mean of these absolute deviations was 1, then obviously the value would continue to remain same, which is basically 16.0417. Now, one may ask that what will happen to the value if we change the weights? If we change the weights, the mean absolute weighted absolute deviation value will change depending on the weights you are assigning. And the weights here I have assigned 1, but many of the examples later on when we see in forecasting will assign weights in such a way that the sum of the weights will be 1. And why that is done, I will come to that in detail conceptually. The value of mean squared deviation. Now, when I consider the mean squared deviation and the value of the variance, only remember in the case of the variance, sample variance, it was divided by n minus 1, while in the case of mean squared deviation, you are dividing by n only. So, the value of the mean squared deviation comes out to be 709.9097. So, in the case of the variance, as it was divided by 11, hence the value was higher, which was 774. I am not talking about the decimal. Here the value comes out to 709 because you are dividing by 12. And what you are dividing by 12 in both the cases are the same, is sum of all the square of the differences between the actual value and the mean value. And if I assign weights of 1 for each of these different square, in the case of mean squared absolute deviation, we have the mean weighted square deviation, and that value comes out to be again 709.9097 because the weights are 1. Again the same concept will be utilized, where the weights which you will assign will all be between 0 and 1, such that the sum of the weights is 1, and we will discuss that as I just mentioned few seconds back when we go into the area of problem solving in the case of forecasting. Now, let us consider there is a second set of number which we mention as y. So, y also has 12 values, as n is 12 and the numbers are, I will just read them out: 2, 7, 8, 9, 10, 11, 12, 13, 14, 15, 150, 186. Now, here I have made a slight change where the values which are there is total number is 12, but each of the value which is there for the set y only occurs once. So, obviously, how you found out the mean, the mode, the median, the variance, the standard deviation, everything can be done for the case of the numbers set y also. So, that I will leave for all the participants and students to just solve it, such that they will understand the methodology, how you find out all the metrics which are important characteristics related to any set of numbers which will be utilized for forecasting. And those were, I am just repeating, mean, median, mode, standard deviation, variance, and subsequently the mean absolute deviation, mean weighted absolute deviation, mean square deviation, mean weighted square deviation. And the last two one were in the slide, if you remember, in the third class for week 1 were covariance and correlation. So, when I try to find out the covariance and correlation using this formula, which was given in the set of slides in third class, the covariance between x and y. X was the data set which we were already considering. Y is this data set which you can see in the slide 33, which is in front of you. And based on that, when we calculate, we find out the covariance as 1452.9, and the correlation comes out to be as plus 0.8416, which means there is a positive correlation, right. And this concept of positive correlation, negative correlation, zero correlation can be very simply illustrated in the graph, which we will take up as we proceed. Now, remember, covariance between x and y is equal to the covariance between y and x. So, there is no difference. And if you have done DADM 1 course, which is there in NPTEL, for which I am the instructor, you will also find out that the covariance of x with itself is basically the variance of x. Similarly, the covariance of y with itself is the variance of y. So, covariance of x and y technically is basically a 2 by 2 matrix, where the element in place 1, 1 is the variance of x, element in place 2, 2 is variance of y, and the elements which are there in the places 1, 2 and 2, 1 are the corresponding covariance between x and y and covariance of y and x. As you note down, and as I mentioned, the covariance between x and y and the covariance of y and x are same, hence the of the diagonal element with respect to the principal diagonal, the values would definitely be the same, which is 145 to 1452.9. So, let us consider another example, which is the fifth one. So, given the data set, which is basically the height versus weight. Height is given in inches, weight is given in pound for 100 individuals, and this data is taken from the UCLA, which is University of California, Los Angeles, statistical department set. if I basically have the data, you can click on the data and have a look. The covariance which you see between x and y, which is height and weight, and why there is a hat there, which I will mark in the yellow, green color, is basically is from the sample. That basically value comes out to be 11.73841. And if I consider the concept of the correlation, again there is a hat, because that is with respect to the sample, then value comes out to be plus 529867. So, there is a positive correlation of about 0.5. I am not reading the decimal places after 5. Now, if I plot it, the next question, the data set. So, what I have, the scatter plot of height versus weight, I basically plot the height which was given in inches, and weight which is given in pound. If I plot that, the whole set of numbers which are plotted, which are the blue dots, are scattered. So, if I remember correctly, they were about 100 data sets. So, if I plot it, the scatter plot is given by the blue, and I fit the best fit line, which would basically a type of regression, which we will consider later on, which can also be considered the type of forecasting which you want to. So, the red line which you see, I am not going to mark, I am just going to put a tick mark such that it does not get cluttered. So, this is the best fit line. What I mean by the best fit line is basically you are trying to minimize the variance or minimize the error of forecasting to the maximum possible extent. And when I am talking about the minimizing the error, minimizing the variance, if you remember, we had discussed mean absolute deviation, mean weighted absolute deviation, mean squared deviation, mean weighted square deviation, and there would be other metric also, based on which we will do the calculations to find out what is the best fit. In this case, we are just using the simple case of mean squared error with weights being equal. So, the weights are not being considered here. Based on that, I fit the red line, which is basically the best fit line. So, as we had discussed about the regression line for height and weight, the data set which was basically 100 in numbers. So, that is basically a way where you are trying to put the best fit line, which minimizes the error. And as you remember, I have discussed, as I was discussing, the error concept can be based on variance, error concept can be based on mean absolute deviation, can be based on weighted mean absolute deviation. There can be many concepts, we will come to that later. So, let us further continue the discussion related to forecasting. So, what are the other concepts which would be important? So, as we were discussing, the concept of covariance and correlation coefficients are statistics, are summary measures that measures the extent of linear relationship between two random variables. So, if you remember, in the case of x and y, the data set which you have considered, where x was 12 in number, y was also 20 in number. Based on that, we found out the covariance and also the correlation coefficient. Similarly, we found out the covariance and the correlation coefficient between heights and weights also. So, but they are all linear in relationship. That means, we are considering a linear relationship between the two random variables. So, the concept of covariance and correlation, remember, is always between -1 to +1, both inclusive. So, if it is -1, it is negative correlation to the maximum possible extent. If it is +1, which is positive correlation to the maximum possible extent, and 0 being there is no correlation between the random variables x and y. So, these two meet this concept of covariance and the idea of correlation coefficient, they can be used to identify the explanatory relationship between the two random variables, which we will see later. But as we remember, we in forecasting, we had measured, and the values of, say for example, mean, values of median and all these things, they were based on random variable x only or y, whatever it is. Now, for the forecasting case, there, if it was regression, that is a different question, but for the forecasting case, you are trying to utilize the past data of the same variable to predict the future values. Hence, rather than covariance between x and y, now it will basically become the autocorrelation between x1 and and the previous value. So, that means if I consider today's value as xt, we would basically try to find out the autocorrelation and also the autocovariance between xt and xt minus 1. How we do that? I will come to that later. So, autocovariance, the concept of autocovariance which I just mentioned, and the idea of autocorrelations are comparable measures that serve the same purpose for a single time series, because you have only one set of data which is basically denoted by x or y, which I have just mentioned. So, we need to find it out and find out that what is the value of the autocorrelation, what is the value of the autocovariance. And these concepts would become more important when we go into the area of time series analysis. Now, let us give us some examples, and these examples would become more important in the forecasting case. Consider we have a data of n observations and they are marked with y as y1 to yn, which I am just circling, and this concept of lag is mentioned here, which is k. Now, very simply, lag would basically depend that how many such time periods based is basically the prediction coming out to be true. So, if the prediction is coming out to be true with respect to the next time period, just immediate next time period, we will consider the lag is basically between the time series data would be 1. If it is basically for 12 months, we will consider for 12. If it is for 24 months, it will be for 12, 24. And I'm saying the months because based on the idea that the data has been collected per month. It can be if the data has been collected per day. So, obviously, the lags would be considered based on number of days. If the data which is presented is based for weekly data, then the corresponding lags would be given in the concept of weeks. Now, we need to find them. So, the concept of autocovariance for the sample considering the lag of k, which k is important. So, this is given by CKV and k means the lag, y is not CKV, y is basically the random variable of the time series. Here also remember you are taking n number of observations. So, obviously, 1 by n is true. There if you remember the concept of the variance, it was n minus 1, but considering n is very large, whether you divide by n minus 1 or you divide by n does not matter. Somebody has to be theoretically correct, then obviously the idea of n and n minus 1 would make sense, but for our problem when you are solving, the value of n or n minus 1 would not make that much of a difference, rather than we need to basically understand the ideas how you do the forecasting concept. So, 1 by n, and what you are doing is that because if the lag is basically 12 months, so that means starting the 13th month till the end data points, you will take the data to basically find out the covariance. So, if I put it, it will be, so you have the data, I will draw it pictorially. So, first data set I will mark in orange. The next one I will mark in, say for example, blue. So, this is basically the and it has been shifted by some set of lags, and this is where k is important. So, if I understand, the k value is basically will depend on the lag which you have, which is k. Now, how it is important in the calculation? If you see the first data set, and if you remember, the first data set has been marked by same data set, but with a lag. So, it is not that they are two broken data set, is basically a continuous one. So, technically the yellow one and the blue one are the continuous time series. So, the yellow part is basically this yt minus the average value. Now, so white and there are n data points which you are considering. So, this is basically related to the yellow one, and if I consider the lags k, because you are going to basically calculate from k plus 1. So, this would be ytk minus 1, again minus the mean value remains the same, because for the whole data set which you have, which you are going to take, and this would be given by this. What is m? I will come to that later on within few minutes. Now, do not confuse this m as the suffix which you had used in mean. Technically, it would mean the mean, but in later on we will see that there would be other subscripts of n, s, m which will be considered. So, in that case m would not basically denote the mean, it will denote something else, we will come to that. So, the concept of lag, concept of s, lag means k, s, small m would be made clear as we proceed and solve the problems. And the autocorrelation of the sample would be, if you consider the idea of correlation, I will use the violet color. So, basically correlation is given by covariance between x and y, the divided by standard deviation of x multiplied, this star is basically the multiplication sign, multiplied by the standard deviation of y. Now, if I basically, and that was the formula which was given and discussed in the third lecture in week 1. So, if I put this idea here, is exactly what will be coming. So, if I consider the idea of this autocorrelation, covariance, which is autocovariance, we have already calculated. So, the autocorrelation is basically given by the formula which is here. This one, wait, let me use a different color. Yes, this is coming into the numerator, and in the denominator it is standard deviation of x into standard deviation of y, but here x and y are the same thing, is the data set. So, it will basically be the covariance of the same data set. So, if you consider the same data set again, mu hat ym is basically the mean value, yt minus that whole square, and you add up for n number of times, divided by n would basically give you the variance. And when I put it in the formula, so here is what the actual autocorrelation concept would be. I will erase all this writing which I have used different colors. The colors were being utilized as that it would make sense to all of us as we are discussing. So, it will basically be the formula where in the numerator you have the idea of autocovariance for the sample with a lag of k, and in the denominator you have the auto variance, basically the variance of it. So, I would not use the auto variance, it is basically the variance itself. And we utilize this concept of autocovariance and autocorrelation in the subsequent calculations. With this, we will end this 4th lecture and continue more discussion about autocovariance, autocorrelation later on with examples in details. Thank you very much and have a nice day.